Do you want to get an A+ in Cambridge IGCSE Physics? Make the smart choice of subscribing to Super Easy Physics and Mathematics. For sure you will benefit from Mr. Matthew wealth of experience of preparing students.
Hello, welcome to SEPAM. Today we are going to explore resistors connected in parallel. In this very particular diagram, we have a battery, you have the rheostat, you have the ammeter, then you have the ammeter 1 that will measure the current through the 20 ohm resistor, and ammeter 1 that will measure the current through the 10 ohm resistor. Then you have the switch for opening and closing the circuit. When you have resistors in parallel, there are three facts I want to share with you that you need to understand about resistors being in parallel. So the first fact, for you to be able to calculate the combined resistance when resistors are connected in parallel, the combined resistance is going to be smaller than the resistance of any of the resistors that are joined or connected in parallel. So we connected in this circuit, you have 10 ohm and 20 ohm connected in parallel. So the combined resistance of 10 and 20 ohm will be a resistor that is less than any of them. So it's going to be less than 10. So what is the formula for calculating the combined resistance? Is 1 over R, which is effective resistance, equal to the sum of the reciprocal of all the resistors connected in parallel. So that will be 1 over R1 plus 1 over R2. Then the second fact, the current in the resistor add up to the main current. So there are two resistors connected in parallel here. So you have 10 ohm and 20 ohm. The 10 ohm is resistor 1, 20 ohm resistor 2. So the current that flow from the battery through this ammeter, which is I, on getting to this junction, divides into 2 depending on the value of the resistance. So we divide into I1 and I2. So if you add up the current measured by this ammeter 1 and the current measured by this ammeter 2, when you add them up, it will give you the current here. So in the next slide, we are going to look at a practical to demonstrate this. So if you don't understand what I'm saying now, just wait, keep on viewing till when we are going to explore resistor in parallel, so you have a better understanding of what I'm saying. Now, let's look at the third fact. When resistors are connected in parallel, the PD across the 10 ohm resistor and the PD across the 20 ohm resistor is equal to the same value. So the PD across resistors in parallel is the same. So since I don't have any other resistor in this circuit, that means the PD across R1 and R2 is going to be equal to the EMF of the battery, or the PD across the battery, which is 20 volts. So the PD across the 20 ohm is 20 volts, and the PD across the 10 ohm is also 20 volts. So these are the facts you need to understand concerning resistors in parallel. So let's go and carry out a practical to explore resistors in parallel, while we'll discuss this fact in detail, and then after that we'll now do a calculation to find this combined resistance. Like you can see, let's open the key. So we have a battery, a 20 volt battery, supplying current to 2 lamps. The first bulb here have a resistance of 10 ohm, while the second bulb have a resistance of 20 ohm. And then we have this ammeter, we measure the main current coming, and then the main current divides into the 20 ohm bulb and the 10 ohm bulb. And then this current measure the current that go back. So we have the switch for opening and closing it. So first of all, let's observe the current, allow the current to flow through the 10 ohm bulb, and then we'll see the current applying Ohm's law. So you see, current is flowing. This is showing the movement of electron. Electron move from the negative terminal down to the positive terminal. So you can see the movement. The yellow part of the battery is the positive terminal, while the black part is the negative terminal. Now, when the battery, 20-volt battery, is powering only the 10 ohm bulb, the current flowing through it is 2 ampere. So how did we get the 2 ampere? You divide the 20 volts by the 10 ohm of the bulb. So V is equal to IR, Ohm's law. So we are looking for I is equal to V over R. So where V is 20 and R is 10. So 20 divided by 10 will give you the 2 ampere. Now you can see the brightness of the light, that is the current is 2 ampere. If we connect another resistor in parallel with this, connect 20 ohm bulb with a 10 ohm bulb, is going to give us a resistance that is lower. So if the resistance reduces, what is going to happen to the current? Will the current increase or reduce? So let's connect it in parallel by closing this switch. Can you see? So did you notice anything about the brightness of the lamp? You can see that the brightness of the lamp, of the 10 ohm lamp, is still 2 ampere that pass through it. So the brightness remained the same of the first bulb because the same 2 ampere that originally was passing through was the same amount of current that is passing through the 10 bulbs amp. So the brightness did not increase or reduce. But you can see this one, the 20 ohm bulb is not as bright as the 10 ohm bulb. So you can see the thickness of the yellow line to tell you that it's brighter than the length also is also longer to tell you that the 10 ohm bulb is brighter than the 20 ohm bulb. The reason is that lower current passed through the 20 ohm resistor because it's offering more resistance than the 10 ohm bulb. So more current pass through the 10 ohm bulb because it's offering less resistance. Then, as we discussed earlier, we said that the main current coming, when it comes to the parallel junction, it will divide into the resistors. So if you look at what is the total current? So we have I1 and I2. So I1 is 2 ampere, I2 is 1 ampere. So 1 plus 2 will give you the current that coming. So that balance up with what we have learned. So we can now go back. So let's go and look at how do we calculate the effective resistance of the resistors that are connected in parallel. So let's go and do the mathematics in the next session. All right. We are going to calculate the combined resistance of the resistors in parallel. So in this case, we have 2 resistors, a 10 ohm resistor and a 20 ohm resistor connected in parallel to a 20 volt battery. Now, if we want to find, so let's look at the first thing here, find the combined resistance that will be produced by connecting 10 ohm and 20 ohm resistors in parallel. So when resistors are connected in parallel, this is the formula you use. 1 over the reciprocal of the effective resistance is equal to the sum of the reciprocal of the resistors that are connected in parallel. So it's equal to 1 over R1 plus 1 over R2. So you have the green resistor and the red resistor. So let's look at it. So if what is R1? R1 is 10. And what is R2? R2 is 20 ohm. So you have 1 over 10 plus 1 over 20. So what is the lowest common denominator? 10 and 20 is 20. So you have 20. 10, how many 10 is in 20? 2. So 2 times 1, that will give you 2. Then you have how many 20 can you have out of 21? So you have 2 and 1, that will give me 3 over 20. Take reciprocal of this. So R is equal to 20 over 3, which is ISO number 2 over 3, which is approximately 2.7, is 2.6667 ohm. So if you see this resistance is less than 10 and is less than 20, about the fact that we talked about the other time, that when you combine resistors in parallel, they produce a combined resistance that is lower than any of the resistors that are combined. Okay. The next thing we are going to do, let's calculate the current flowing through each of the resistors. Now find the current flowing through each of the resistors. For you to be able to calculate the current flowing through each of the resistors, you need to remember that the PD across resistor in parallel is the same. So what is the PD across this resistor? Is going to be equal to 20 volts. So the PD across the 20 ohm is 20 volts. The PD across the 10 ohm resistor is 20 volts. So V1 equals to V2 and equals to, what is the PD of the PD across a resistor is the current flowing through the resistor multiplied by the resistance of the resistor. So I1 times R1 is equal to I2 times R2 because the PD is the same, which is equal to 20, which is the PD of the EMF. So let's substitute. If we know what we are looking for is the current, so let's solve for the current I1 that will be measured by ammeter A1. So if you have that, so make isolate of formula. Since I1 R1 is equal to 20, so we have 20 divided by 10, that will give me 2 ampere. So that is the current that will flow through the resistor 1. The 10 ohm bulb is going to be 2 ampere. Now let's calculate for the second bulb, the resistor 2. So we still have the same, the PD across it is 20, so divided by the resistance, so 20 divided by 20 will give me 1 ampere. So if I told you that I1 plus I2 will give me I, which is the current that is divided into each of them. So 2 plus 1 will give me 3. So I said about the fact that the current flowing in resistors in parallel add up to the current that was divided. So ammeter 1 will measure the make current coming, then ammeter A1 will measure the current through resistor 1, and then A2 measure the current through resistor 2. So when you add the current through this and this, will give me this major current. So with this, we have been able to discuss the property of current. Now, before I go, there's another thing I need to explain, that when resistors are connected in parallel, if you switch off one of the resistor, the other one will still be working. And that is how the lamp in your sitting room are connected. If you turn off one lamp, the other one will still be working because everything in the house are connected in parallel, the wiring of the house. Your television, if it's off, your AC can still be working because the AC and the television are connected in parallel.